All right, hi, ladies and gentlemen. So as this is coming up, I just want to say hi. Sorry I'm not here today, but I want to talk through all the examples that I have for Chapter 5. First thing that you should do is get out your exam review and start checking the Chapters 3 and 4 assignments that I have on the key here. So pause when you need to and just kind of go through it and make sure you have all the questions right. Remember to correct anything that we need to so that you can turn it in. Make sure this is on separate sheets of paper, not on the actual packet. You know the drill. So I'm just going to scroll through, so pause where you need to. And here's Chapter 4. Now 39, you can really have whatever story you want. This is just one that we have here on the key. And then here's 40 and 41. All right. So if you have any questions over those, I can definitely go over them when I see you again on Tuesday. But other than that, hopefully we can understand basically from everything from the key. One thing that I wanted to mention, now I said it in some of the classes, but I did not on others. This is really important. You are allowed a note card. Yeah. I don't think I mentioned this to second period. I know I did to third period, and I'm not sure about eighth. But you are allowed a note card. Here are the rules. It must be a 3x5 note card. Must be a 3x5 note card. And you can write on the front and the back. Front and back. Okay. You're going to turn it in. You're going to have your name on it. And you're going to turn it in with your exam. So you can't pass it to your friend who's in the next exam. I want everybody's note card, turned in with their exam. So things that I would put on the note card, any formulas, any, ways to do certain problems. You can really write anything you want on it. So that's totally up to you. So maybe something you might want to do today if you have some extra time, or maybe some extra time over the weekend. Maybe you're snowed in on Saturday and you can't go anywhere. That's a fun Saturday night activity. Make your note card for your math exam. Yeah, that sounds like fun. My kind of fun. All right, so let's take a look here. So these are I'm just going to go through the problems that I would have gone through if I was there with you. So find the slope of the line that contains these points. Now remember that the slope formula is y2 minus y1 over x2 minus x1. Maybe something that you might want to put on your note card. So we say 3 minus 4 over -7 minus a -6. Okay, remember y2 minus y1, 3 minus 4 over x2 minus x1, -7 minus a -6. Watch out for that minus a negative. This should be -1, -1. This should be a plus here. So -7 plus 6, -1. -1 divided by 1, +1 slope. So m equals 1. There's my answer. Okay, let's keep it going. Find the slope of the line that contains the points 5, 8 and 5, 2. So again, my slope formula is y2 minus y1 over x2 minus x1. So that gives me 2 minus 8 over 5 minus 5. Now, when we do this, we get, -6 divided by 0. Now, what happens when we divide by 0? Undefined. Okay, watch out for that. That's an N. Undefined, where you cannot divide by 0. So don't, think about what type of line that is. If I'm just drawing it, 5, 8, 5, 2. That's a vertical line, undefined slope. Okay, let's keep it going. Find the x and y intercepts of the following, then graph. Okay, so taking a look at the intercept, remember that to find the intercepts, what we're going to do is plug 0 in for x, solve for y, and then plug 0 in for y and solve for x. So let's do this first one here. Let's plug 0 in for x. -4 times 0 plus 2y. Oh, yeah, that's right. This is this thing where this will completely go away. leaving us with just a 2. Y is equal to negative 16. Divide by 2, y is negative 8. Now, on the flip side of that, plug 0 in for y, we get negative 4x plus 2 times 0 is equal to negative 16. So we get negative 4x. Look, that's going to go away. 2 times 0 is just 0. Negative 16 divided by negative 4. X is positive 4. So 4 comma 0. Now, this is my y-intercept. Remember, y-intercept goes on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8 down there. This is my x-intercept. 1, 2, 3, 4. So my line, now it's hard to kind of draw lines with this pen that I have here. Do not make fun of my line. Okay, you can make fun of it. I'm not there, so who cares? Okay, find the slope. Now remember, slope is rise over run. So you take nice point to nice point and say down 1, right 1, 2, 3, 4, 5. Down 1, right 5. Slope is negative 1/5. Now remember, you should see that if you're calling it a negative slope, you should see the crossbar to an n. That makes an n, right? You should all be saying yes. Yes, it does, Mr. Lavery. Slope of a vertical line, we just talked about that. Remember, picture the skier on the slope here. Undefined. Okay. Picture the skier on the slope here. Oh, this has a slope. So it's rise 2, run 2. Remember, think about it. Always use a fraction and reduce it down. Rise 2, run 2, positive 1 slope. Don't forget slope of a horizontal line. That's what I was thinking before. Slope of a horizontal line always is going to be 0. The slope is going to be 0 there. Yeah. Okay. Now, when I don't have 2 points to take the slope from, I just generate those 2 points. The easiest 2 points to get are the intercepts. So let's find what the intercepts are. Plug in 0 for y, and we end up just getting 4x is equal to negative 48. So x dividing by 4 would be negative 12. Plug in 0 for x, and I end up getting negative 3y is equal to negative 48. 48 divided by 3 is 16, I think. Yeah. And so we have, this is negative 12 comma 0 and 0 comma 16. And then you could just do the slope formula with that. 16 minus 0, y minus y, over 0 minus a negative 12. So this is 16 minus 0 is 16. 0 minus negative 12, that's 0 plus 12, 12. Reduce it down, divide both top and bottom by 4. We get a 4 over 3. Remember, no decimals, no mixed numbers, just fractions. Okay. Yeah, that's the same thing. Let's keep it moving. Oh, direct variation. Remember, direct variation is the form y equals k times x. Maybe another thing you might want to write down on your note card. Is this an example of a direct variation? Well, we have to see if we solve for y, is there any addition or subtraction? Because if there's addition or subtraction, it's definitely not a direct variation. So let's subtract 6x over to the other side. So just solving for y, I get negative y is equal to negative 6x. And to get rid of the negative, you just divide by negative 1. So that gets me y is equal to 6x. Is that a direct variation? Yes, that's a direct variation. Just a number times x. Is this an example of a direct variation? Well, I don't know. Let's solve for y. Subtract the 2x over to the other side. We get 4y is equal to 6 minus 2x. Divide by 4. I get y is equal to 3 over 2. That's when I reduce that. Minus x over 2. Do I just see a number times x there? No, I don't see a number times x. So that is not a direct variation. Okay. That's just another example of that. We'll keep it going. Got a lot to do here. Okay, now this one's a weird one. This was one of the more commonly missed problems on the test that we had over this. So remember that it's direct variation is y is equal to k times x. Now, I tell you that y is 6 when x is 4. That's going to tell me what my equation actually is. So if y is 6 and x is 4, if I divide 4 over to the other side, 6 divided by 4, let me get a calculator up here. 6 divided by 4 is 1.5. So 1.5 is equal to k. Now, what's my equation based off of that? Well, that means it's y is equal to 1.5x. Now, it says, then determine the constant of variation. Done. Write the direct variation. Done. Then find y when x is 19. Y is equal to 1.5x, so y is equal to 1.5 times 19. Okay. 1.5 times 19, 20.5. And there's my answer. Okay, let's keep it moving. Write an equation of the line in slope-intercept form with slope 4 through point 0, comma negative 3. Oh, easy, easy, easy. Why? Because that is the y-intercept. Remember, it's y equals mx plus b. Another equation. Maybe I might write that down on my note card. So we have the m, slope is 4, the y-intercept, negative 3. So that means we have y is equal to 4x minus 3. Now, we graph that by taking the y-intercept of negative 3 and then using my slope, 1, 2, 3, 4, over 1. Remember, it's always over 1 if it's a whole number. 1, 2, 3, 4 over 1. Okay, again, do not make fun of my line drawing skills. Oh, yikes. It's hard with this pen, okay? Relax. All right. Now, when I don't have my y-intercept, when it's just a point given, I've got to work a little harder. So remember, we have y is equal to mx plus b. Okay, so I've got my slope is negative 3, but I don't know my b value. So let's use this point to find the b value. I know I've got negative 2 comma 5 as my x and y coordinate. So that means I can take y, which is 5, is equal to m, which is negative 3, times x, which is negative 2, plus b to solve for b. So 5 is equal to 6 plus b. Sorry, that's a 6. That's a b. Subtract 6. I get negative 1 is equal to b. So y is equal to negative 3x minus 1. That's my final answer. Okay. Graph that line, well, that's really easy to do with my slope and my intercept. My y-intercept is negative 1, and then my slope is negative 3, so I can go down 3, right 1. Or I could go up 3, left 1. Up 3, left 1. That's one of my better lines there. Okay. A couple more problems. By a couple, I mean a lot. All right, write the equation of the line in slope-intercept form through those 2 points. All right, first thing I've got to do, again, slope-intercept requires us to get the slope and the intercept. And I don't even know my slope this time. So I take y minus y over x minus x. So we get 7 minus 4 is 3. 2 plus 4 is 6. Oh, look at that. Reduces nice and easy down to 1/2. Now, this is the time where I can pick the point, right? Pick that point, 2 comma 7. And we could say y is equal to m x plus b that I haven't found yet. 7 is equal to 1 plus b. 6 is my b value. So that means my equation is y is equal to 1/2 x plus 6. There's my answer. Okay. Now, parallel and perpendicular slopes. You know, what is the slope parallel to these slopes? Well, remember, the slope parallel to 2 is 2. The slope parallel to negative 1/4 is negative 1/4. Remember, parallel lines have the same slope, whereas perpendicular lines have what's called, again, opposite reciprocal slope. So 2 is going to correspond to a 1/2, but negative. Negative 1/4 is going to correspond to a positive 4 over 1, or just 4. Remember, opposite reciprocal. Flip it, and take positives to negatives. So write the equation of the line parallel to this line. Well, remember, the only thing that I care about is that slope. So my new slope is -3, and I know it runs through 0.1, 5. Okay, we're back to what we did on the last couple slides. Do I care about this 4? Nope. I only care about the fact that this slope was -3. I want my new slope to be -3 as well. -3 going through this 0.1, 5. So I go back to trying to solve for b. So I say y equals mx, and y and x come from here, plus b. 5 is equal to -3 plus b. Add the 3 over to the other side. 8 is my b value. So that means I've got y is equal to -3x plus 8. Now, jumping back to these equations, don't we see that y is equal to -3x plus 4 and y is equal to -3x plus 8? Those have the same slope. Those lines are parallel with one another. Now, perpendicular, however, requires a little bit more work. This slope is no longer just copied. What I have to do is actually take the opposite reciprocal. So opposite reciprocal of -3 turns into +3, and it's the reciprocal, so 1/3. And it goes through this point, -6, 2. So got to find my b value. So I say y equals mx plus b. Again, y and x come from here. So 2 is equal to -2 plus b. And I add the 2, I'm going to get 4. Sorry for the no room down there. So 4. So y is equal to 1/3 x plus 4. There is my answer. Right? You're just trying to solve for these two things. All right. Last thing that I want to take a look at here is the parallelogram, and I basically just want to say, okay, is this a parallelogram, and how can we be sure? Well, we have to look at the slopes. So what's the slope here? Rise 4, run 1, -4. What's the slope here? -4. What's the slope here? 3/2. What's the slope here? 3/2. You see that? Opposite sides have the same slope. Opposite sides have the same slope. Now, what I can do now for a right triangle is to show that this is perpendicular. Well, what's the slope here? This is rise 3, run 2. +3/2. What's the slope here? Down 2, right 3. Look at the two slopes. You have to show that the two slopes are opposite reciprocals of one another. All right, I know I kind of breezed through those problems, but hopefully you can pause, go back, and rewatch if you need to. Yeah, I hope we're all having a good day, and don't miss me too much. All right, see you. So long.